So I guess I'm going to give this talk. I was told I was giving a keynote last night, so I asked myself, what would the NewSpace audience want? What would the new entrepreneurs want? I wanted to talk about a little bit about imagination and how imagination started my company and how imagination is being applied to start new and innovative businesses. I think if we take a look at something like SPACEX, their imagination was, could we have a second home? That's a very profound statement for a company. It's not like I want to build a rocket company. It's something very different. To get there, he proposed something else that was very innovative, very imaginative. To rethink, could we make a reusable rocket? Oops. But it leads to other things of, what if I could send a mission to deep space? Maybe I'd send a red Tesla as a way of co-marketing for my other company. It's better than sending ballast. So it's very imaginative. If we take Blue Origin, when they're talking about millions of people living and working in space, this takes a lot of imagination. It's not saying, I want to build a rocket company. It's saying there's another purpose. They may also want to have millions of elk living and working in space. This is from the Blue Origin presentation, but a beautiful rendering that goes back to some of O'Neill's designs of space stations. Some friends at the ARC mission, which is almost a non-for-profit startup, if you will, they asked themselves, what if you were doing something like the Foundation? What if you wanted to preserve humanity's knowledge? Well, they designed these little data disks. And in a very entrepreneurial way, they asked Elon Musk on Twitter, could we fly these in the glove compartment of the Roadster? And they did. And this happened very, very quickly. They were also on the Bare Sheet Lander, where I was told by the founder, and I was very surprised, that they had pictures of all the founders on their data archives on little nickel plates. And so a picture of me as an advisor is now sitting on the moon at the crash site of the Bare Sheet Lander. But this is using some imagination. This is a space nonprofit, but they're asking themselves, what could I do in space? They're being very innovative. We can go back to a much older company. CELESTIS is almost 20 years old. They've flown memorials and ashes on 25 space missions. Something that probably wouldn't occur to you, but I'm kind of comparing. You can have very, very big ideas in space, but you can have very, very doable small ideas in space. See my friend Michael over there at Extronaut, who's doing games to involve people in space. It's another example of something that anyone can do if you're a good game designer and you love space. So what inspired me? When I look back, I was 3 years old. My mom says I was crying when they landed on the moon. I didn't have that Apollo experience, despite the fact that it's the anniversary this weekend and I'm going to celebrate it. That wasn't my inspiration. My inspiration was Voyager. In magazines, in newspapers, I was seeing images, on this grand tour of the solar system, where we were getting these wonderful images of storms on Jupiter, volcanoes on Io, one of the most interesting spots in the solar system, the moons of Saturn, detailed images of the rings of Saturn. These were the first times we were seeing these in high resolution when I was a child. Uranus, not a whole lot to look at, very simple planet. And this, sorry, my clicker, there we go. This is still one of the only images of Neptune. It's only been visited by Voyager. There's so much more to explore in our solar system. One of the more interesting images they took, they looked back. They looked back at Earth and took a portrait of the entire solar system with every planet. And in one of these images, this was done at the urging of Carl Sagan, there was a pale blue dot. It was practically just 1 pixel. You may have a hard time seeing it on the monitor. That was Earth. This was a completely new view of our place in our solar system. And it made us feel very small. I imagined Explorer. that what would happen if I wanted to accelerate space science, deep space missions, doing them commercially? We know that we're hungry for this knowledge. We want to know more about our solar system. We know there's a transition between from government run space missions to commercial industry. And we're seeing this with commercial cargo, commercial crew, the CLIPS program at the moon, a commercial station with Axiom and Bigelow and other companies. This science data is being used today. When we go to science conferences, we see people still analyzing the Magellan data from 30 years ago, the last US mission to Venus. We see people looking at this Voyager data, 50 years past when they flew past these planets. Explore was designed to provide hosted payloads, so services and exclusive data to our customers. And the reason we're doing these things is to accelerate space science, that we can take the spacecraft out of the mission. Explore is essentially designing the mission, and scientists don't have to design spacecraft, they can design their scientific instruments to answer the scientific questions that they have. In doing this, I'm going to simplify the spacecraft design methodology. We have great systems engineers who've worked on literally hundreds of missions between our team of 25 people. But you have to ask yourself, what is the right exploration spacecraft? What is the right size? How much propulsion do you need? How much payload can you carry? As that drives your revenue potential as a commercial business. Communication, deep space is extremely hard. And how much power do you have if you want to operate like our company wants to operate between Venus and Mars? How do you find the answer to this question? I think our CTO answers every question is that every spacecraft question can be solved with a bigger antenna in many cases. Oops. When we started looking at missions, we were thinking about doing something like the CubeQuest Challenge, where we could go to the moon on a demonstration mission. But it turns out that there was nothing repeatable about doing a CubeSat mission. It wasn't powerful enough, it didn't have propulsion, I couldn't carry a lot of instruments. It was just too small for us. More advanced CubeSats that get a little bit larger with large deployable antennas, now you start to get to something interesting. But can this operate at Mars? We've seen the Marco satellites operate at Mars, but there was very, very limited payload. And once they flew past Mars, they very promptly died. And that's not a repeatable mission to have something so small and so expensive. So if I go in the other direction, I want something large. Well, Death Star has a wonderful antenna. It's going to require millions of SLS launches to assemble it. And it did have some critical flaws in testing that were not discovered. So I don't think we can do that. Now, another spacecraft from the other team, if you will, that has a wonderful antenna, but again, very, very large. And here we're getting just about right. We want a smaller spacecraft with a big antenna, a lot of propulsion, very agile. And all kidding aside, it comes back to something like Voyager. If you want to do interplanetary missions, you end up with these spacecraft that look like antenna craft. Right? If you want to operate at distance, the antenna is very, very important. What Explorer has done over the last 2 years is develop a spacecraft that's ESPA size, so we can fly on any different launch vehicle, has extensive propulsion, a very wide payload capacity that can do planetary science, heliophysics missions, astrophysics missions. And that antenna, I can't stress the importance of the antenna. That's a 1.75 meter antenna. We get fantastic data rates from Mars. This is comparable to flagship missions that have been run before. And having good power capability, so it's 550 watts on the bus. This is a work of art in terms of spacecraft design. And we plan on using this for missions for sovereign nations and our own missions where we can bundle payloads from around the world to Venus, Mars, Earth's moon, and near-Earth asteroid missions. I'd like to ask anyone in the room who's a scientist or a marketer or someone who isn't designing a spacecraft, what is a payload that could go on these missions? You know, is there a way we can help you? We're in discussions with many scientists and brands right now, and it's many people, if you don't have to design the spacecraft, you don't have to design the mission and the ConOps and the communication, this provides you with a platform to make your business and a platform to make your applications, whether it's on top of our spacecraft or on top of the data coming back from our spacecraft. So that's all. I hope I provided you a little entertainment at the end of the day. I know it's been a long day for everyone. Thank you. Questions or, yeah, happy to take a question or two.
Does this spacecraft have any application towards like the NASA Clipper missions? Like, could you run this past Europa and sniff for life in the plumes?
It's probably a little bit too far. So our operational distance is Venus to the asteroid belt. When you get past Jupiter, there's not enough solar power to run the spacecraft. So we'll switch to electromagnetic tethers a decade down the road. So it's a difficult environment to operate. You need much, much bigger panels to operate past the asteroid belt.
What about asteroid visits?
We have some wonderful asteroid missions designed and can go to asteroids. People can design payloads that are impactors or landers for those asteroids. So our payload bay is big enough to handle other small spacecraft. So up to 6 U CubeSats, multiple 6 U CubeSats can be deployed. Or impactors or sounders for atmospheres. Anything you can imagine. So, I'm sorry? Sample return gets really difficult, but I'm willing to hear what you are imagining. There was a question over here.
Hi, I'm Alan Boyle with GeekWire. I think you had discussed in an email recently that you were hoping to have the XCRAFT ready in the 2021 timeframe. Can you talk a little bit about what the opportunities might be? Do you have people who are looking to use your spacecraft to put payloads in toward particular destinations?
Sure. The spacecraft development has proceeded to we're achieving PDR or finishing PDR on August 1st, CDR by the end of the year, and in 2020 we'll be assembling the spacecraft. So this is for launch in 2021. So as we achieve CDR, we're actually in active negotiations with different government agencies and with commercial companies on launches. And we can launch on anything because we decided on this ASPA format, we can launch on practically any vehicle going to GTO or a cislunar launch from Blue Origin, for instance, which is scheduled in 2024, so we're looking at other options that are a little faster. Thanks, Alan. Any other questions? You can't ask a question, you're my wife. We have an absolutely wonderful team. Many of our sales and strategy staff are up here in Seattle, like Lisa Rich, who's my wife and partner at Hemisphere Ventures. But the spacecraft team is actually distributed in Utah, Boulder, and El Segundo, California. So these are just experts who happen to be distributed.
What's your approximate double?
2,500 meters per second, which can be expanded through additional tanks in the payload bay.
I just have a suggestion for a possible mission. There's a lot of talk about the Martian moons, and I think a good opening move for this type of NewSpace craft would probably be to do something that's totally out of the ordinary, and that can get a lot of media attention to stimulate the public's imagination.
Sure, that's a wonderful idea, and we've considered Phobos and Deimos missions. They're actually easy orbits to get into, and we can deploy landers or impactors to the surface because they're very low gravity, very much like a small bodies mission. Thank you, everybody.